Today, my topic of presentation is compounds of biological origin that dissolve mostly in non-polar solvents such as chloroform and diethyl ether. The lipids come from a Greek word lipos means fat. Unlike carbohydrate and proteins, which are defined according to their physical operation, means whether they are unsaturated. These are the structure of lipid. This is a triacylglycerol, which is a basic structure of fat, menthol, vitamin A, phosphatide, cholesterol, which is a steroid hormone. Triacylglycerol is the mostly used form of lipids. Extractions of lipids. Lipids in hydrophobically associated form are extracted with relatively non-polar solvents such as ethyl ether, chloroform, or benzene. Those lipids which are membrane associated means they have double layered in each cell, require polar solvents such as ethanol and methanol to cleave for the cleavage of hydrogen bonding or electrostatic force between them. Those lipids that are covalently bound are not extracted directly by solvent, but first of all, we have to cleave their bonding by acid or alkaline hydrolysis. The chemical nature of lipids is also taken into consideration in choosing an extraction procedure. Fatty acids and triacylglycerols. Only a small portion of total lipid fraction obtained by extraction with a non-polar solvent consists of long chain of carboxylic acids. Here you can see most of the carboxylic acid of biological origin are found as ester of glycerol. Hydrolysis of fat or oil. Hydrolysis of fat or oil produce mixture of fatty acids means when we treat a compound molecule of fat or oil in the presence of water and hydroxyl ion, and when we heat them they become two molecules, a glycerol molecule and a fatty acids molecule, free fatty acids. Unsaturated fatty acids. Unsaturated fatty acids, the double bond are all cis. Many naturally occurring fatty acids contain two or three double bond. The fats or oils that these come from are called polyunsaturated fat or oils. The first double bond of an unsaturated fatty acid commonly occurs between carbon 9 and carbon 10. The remaining double bond tends to begin with carbon 12 and carbon 15. In linoleic acid and linolenic acid means omega-6 fatty acids and omega-3 fatty acids. They have the double bond on begin with carbon 12 to carbon 15. The double bonds therefore are not conjugated. Triple bonds rarely occurs in fatty acids. Saturated fatty acids. The carbon chain of saturated fatty acids can adapt many conformations but tend to be fully extended because this minimizes steric repulsion between neighboring methylene groups. Neighboring. Next, saturated fatty acids pack efficiently into crystals, and because dispersion force attractions are large and they have high melting points, and these melting points increase with the increase in molecular weight. The cis configuration of the double bond of an unsaturated fatty acid puts a rigid bend in the carbon chain that interferes with crystal packing, causing reduced dispersion forces between the molecules. The unsaturated fatty acids mostly have lower melting point. Fatty acids known as omega-3, this is also known as a good cholesterol fatty acids, are those where the third to last carbon in the chain is a part of carbon-carbon double bond. Long chain omega-3 fatty acid incorporated in diet and believed to have beneficial effects in terms of reducing the risk of heart attack and easing certain autoimmune diseases, including rheumatoid arthritis and psoriasis. Rheumatoid arthritis is a inflammation of joints, And psoriasis is a skin disease in which cells multiply more than normal. These are some common fatty acids. These are saturated fatty acids. We can see here long chain at the last hydroxyl ion, and these are unsaturated carboxylic acids. We see the double bond here. Hydrogenation of triacylglycerols. Solid commercial cooking fats are manufactured by partial hydrogenation of vegetable oils. The result is a familiar partially hydrogenated fat, means the fat is partially hydrogenated, present in so many prepared food. Completely hydrogenation of the oil is avoided because a completely saturated triacylglycerol is very hard and brittle. Polyunsaturated oils tend to react by auto-oxidation, causing them to become rancid. Rancid means a molecule uh, that have a unpleasant smell or taste. This is the hydrogenation of an unsaturated fat. When it reacts with hydrogen and in the presence of nickel, it becomes a saturated fat. Here we can see unsaturated fat, a double bond, and this here long chain. Saponification of triacylglycerols. Saponification is the alkaline hydrolysis of triacylglycerol leading to glycerol and mixture of salts of long chain carboxylic acid. Here, this is a molecule of fat. In the presence of water, it will give us a molecule of glycerol and sodium carboxylate. With the three molecule of sodium hydroxide. These salts of long chain carboxylic acid are soaps, and this means this molecule is basically a soap. And this saponification reaction is where most soaps are manufactured. Fats and oil are boiled in aqueous sodium hydroxide until hydrolysis is complete. Adding sodium chloride to the mixture then causes soaps to precipitate. Sodium chloride is added for the precipitation of the soap. After soap has been separated, glycerol can be isolated from the aqueous phase by distillation method. Crude soaps are usually purified by several precipitations. These are then several aromas are added for the desired product. So several perfumes can be added for aroma for the desired product. Reaction of the carboxylic group of fatty acids. Here, when a fatty acid reacts with lithium, will in the presence of water, this molecule is basically lithium aluminum hydride. This is a iopic name of this molecule, and this is called lithium tetrahydroaluminate 3. When it will react, it give us long chain of alcohol. When fatty acids react with alcohol, it will give methyl ester. When it react with bromine and phosphorate, it will give bromine haloacid, alpha haloacid. And when it react with thionyl chloride, it will give long chain of acyl chloride. Metabolism of triglyceride. Basically, the lipid in the presence of water digested, and the digestive enzyme is called lipase enzyme, and this fatty acid is converted into a molecule of fatty acids, free fatty acids, and glycerol. Glycerol is metabolized in the adipose tissues where the fats are stored, mostly in animals and in humans, and fatty acids are metabolized in the cytoplasm because there is no enzyme in the adipose tissue for the metabolism of fatty acids. So it will metabolized in the cytoplasm. Triacylglycerol will react with water in the presence of a gastric lipase enzyme, and it will convert into diacylglycerol and free fatty acids. Then they are further metabolized for the energy production. Biological function of triacylglycerol. The primary function of triacylglycerol animal is an energy reserve because we know animals needs more energy than humans. When triacylglycerol are converted to carbon dioxide and water by the metabolism reaction process, they yield more than twice as many kilocalories per gram as do carbohydrates and protein. This energy is large because of the presence of carbon hydrogen bonds per molecules. High proportion of carbon hydrogen bonds are present in each molecule. All of the saturated triacylglycerols of the body and some of the unsaturated can be synthesized from carbohydrates and protein. Certain polyunsaturated fatty acids, however, are essential in diet of higher animals. The amount of fat in the diet, especially the proportion of saturated fat, has been health concern for many years because this can cause a heart attack, heart disease, and cancer if taken in a wrong way or in high proportion. In animals, specialized cells called adipose fat cells synthesize and store triacylglycerols. The tissue containing these cells, adipose tissue, is most abundant in the abdominal cavity and in the subcutaneous layer. Men have fat content about 21% and women have 26%. The fat content is sufficient to enable us to survive starvation for 2 to 3 months because when we, for example, when we are fasting, we need energy. So the fat from the adipose tissue are start to metabolize and give us energy. Application of lipids, fats and lipids are important because they serve as an energy source as well as storage for energy in the form of fat of cells in the adipose tissue. They also have a major cellular function and structural component in the cell membrane because they provide a barrier for the transportation. They only transport nonpolar agents, act as a shock absorber to protect vital organs and insulate the body from the temperature extremes. Means in winter they provide us energy as well as they regulate our body temperature. These membrane association with carbohydrates and protein regulate the flow of water, ions, and other molecules into and out of these cells. Hormones, steroids means cholesterol, and prostaglandins are chemicals messengers between body tissues. Application of lipids, vitamin A, D, E, and K are lipid soluble and regulate critical biological process. Other lipids aid in vitamin absorption and transportation. This is the structure of vitamin A. This is the structure of vitamin D, vitamin E, and vitamin K. Here we can see the attachment of methyl group, hydroxyl group, ring structure. Thank you. That's all from my side.